Result Analysis. Hello everyone. Welcome to this learning video on result analysis in StarCCM+. In this session, we will see how to analyze CFD results using various post-processing tools in StarCCM+. This video is part of the Learn CAX course on CFD modeling using StarCCM+. First, we will establish the fundamental idea of CFD result processing in StarCCM+. StarCCM+ allows us to analyze the solution at two instances. First, while the simulation is running, and second, when it is complete. As you start using StarCCM+ for result extraction, you will find this feature very interesting as well as beneficial. All that result analysis is based on is the concept of field functions. What is this field function? A field function provides access to raw simulation data and to data computed from the raw data. There are three different ways in which we can see field function. First is creating reports. In this, we can create reports of specific quantities. 4 different types of reports can be created. Also, reports can be monitored while a simulation is running. In the second method, we can visualize the solution data. The view can be of scalar or vector. The concept of scenes is used here. If we create scenes before starting simulation, these scenes get automatically updated as the simulation calculations progress. Third, we can create plots. The plots are of data that is extracted from the solution. These include monitor, residual plots, XY plots, and histogram plots. Whichever method we use, the basic working concept remains the same. The general process is to choose parts on which we see field functions. Then use any of the 3 methods to extract data of field function from or on that part. Such parts can be regions, boundary surfaces, or derived parts. Derived parts are additional lines and surfaces. These we can create in addition to the surfaces already present on geometry parts and regions. Let us see in detail what a derived part is. A part that is based on another part is known as a derived part. A derived part is created using one or more other parts as parent parts. It is also dependent on these parent parts. If any of the parent parts change, all parts depending on those parent parts are automatically recalculated and redisplayed. Let us see how to create a new derived part. To add a new derived part, begin by right-clicking the Derived Parts node. Then, choose a part to create from the New Parts submenu. 2 items in the submenu are derived part categories with their own submenus. Another method is to use the in-place dialog. It will appear as soon as we execute this pop-up menu action. We can also define the part using its properties. We said that there is an in-place dialog which appears to create a derived part. Let us see that process in detail. When we execute the action for adding a derived part, typically an in-place dialog appears. It will come in the Edit tab of the simulation window where we can define the part in detail. This dialog is connected to the particular scene that is active when it opens. It disappears when the scene becomes inactive. There are some inputs required for the in-place dialog. 1. Click the Input Parts button to select the input parts that you want to include in the derived part. 2. The other features in the dialog you are using depend on the type of the derived part. 3. The Create button implements the settings that you entered in the rest of the derived part dialog. 4. When you finish setting the parameters, click Create to put your specifications into effect and to add the part to the simulation tree. 5. Then, click Close. Slide 5. The other way to edit or create derived part is the Properties window. If we do not want the in-place dialog visible, make sure that none of the scene displays are active. Then, right-click the Derived Parts node and choose a part to create. A new node appears under the Derived Parts node, which we can visit and adjust the properties that define the part. We saw that the in-place dialog appears only for some cases and does not appear in some cases. What are the exact conditions when in-place dialog can be used to create derived parts? For creating a derived part with the in-place dialog, certain conditions must be met. Then only the in-place dialog will appear in a scene display. Let us see these conditions one by one. 1. A scene display should be active. 2. Another derived part is not being edited in the current scene. 3. The derived part that you are selecting is not already being edited in a scene. Let us now learn how to create derived parts. We will see only the most popular derived parts. First is the plane section. The plane section is an implicit part that is derived from one or more input parts. The node of a plane section has its own properties and pop-up menu. It is located in the Derived Parts node of the simulation object tree. What is a plane section? A plane section uses a plane as the implicit function to cut. The output is dependent on the topology and discretization of the input parts. The exact form of output depends on the dimensionality of the input parts. Input data consisting of 3-dimensional cells result in output surfaces. Input data consisting of 2-dimensional cells result in output lines. And input data consisting of 1-dimensional data result in points. For creating planar section, we must have part. This part can be regions, boundaries, and geometry parts. Let us see how to create plane section. To create a plane section, right-click the Derived Parts node. Select New Part, then Section, and then Plane. Typically, an in-place dialog would be used for this process, and it would appear as soon as you execute this pop-up menu action. If the conditions for activating this dialog are not met, then this action causes the new plane section to appear in the simulation tree immediately. Another way to create a plane section is with the toolbar button. We can use the Create Plane Section toolbar button to create a plane section in an open scene display quickly. The plane is defined with 2 points that you specify. First, position the image in the scene so that your view is exactly perpendicular to the plane. Then, click the toolbar button. After this, click at 2 points in the display to define the plane. Then, select a displayer in the dialog. We can choose one of the existing displayers, or create a new one, or create the derived part without assigning it to any displayer. The plane section appears in the scene. How does the plane section look after creation? Once we have finished the creation process, we can use the rotate and zoom in the display to get a clear view of the plane section. An example is shown here.